Okay, we're going to talk about power supplies and focus on benchtop power supplies and the basic use and connecting these and how you would use them on a bench to power equipment. So let's generally talk about power supplies. They come in. Uh, it's maybe a pretty complicated topic, but they come in three basic setups or types, and that would be unregulated, linear regulated power supplies, and switching power supplies. And to explain those very quickly, you have to get the perspective, and that is there's an input voltage that comes into a power supply, and then the power supply circuit takes that and gives you either a DC voltage or an AC voltage that you want to set up to work your equipment. So that might be 5 volts, it might be 8 volts, it might be 12 volts, 24 volts, and AC supplies. So we're going to focus on DC supplies, and very quickly, the unregulated, those usually show up as the wall wart type supplies where everything's in that little black box that you plug in by your AC outlet. And some wall warts are regulated, some aren't regulated, but basically an unregulated power supply, when you change the load that you have connected to the power supply, when you draw more current, the original voltage that you set up to supply was probably going to change. It's not regulated, so the output load changes the voltage that's there, and that's an unregulated supply. Then there's uses for them. They're inexpensive. There's linear regulated supplies. Usually we're talking about the output voltage as opposed to the input voltage, and that's where our focus sits. And if you have a DC voltage coming into a linear regulated power supply, it has to be a little bit higher than you want to go out. So say you wanted 5 volts out, you'd probably have to have some range like 7 to 20 volts on the input, and it's regulated, so no matter what happens with the load within limits that you have connected to that power supply, it'll maintain the output voltage you want. The other topic that we're not mentioning too much or sort of staying away from is filtering, and that gives you a really nice straight line if you're looking at your DC output voltage with a scope. Switching power supplies, the circuitry that provides the power is rather complex. Usually one of the focuses is the AC input voltage for that can widely vary. So you can have a 110 volt or a 220 volt AC source, like say you're using it in different countries, and the switching power supply design works well with that, and that's why a lot of modern computer supplies are switching power supplies. The other thing a switching power supply does is the internal components can be much smaller because of the design, and there's less heat waste, so they can be smaller, they're more efficient, but for the most part, you want 5 volts output, you hook something up, the power supply does the same thing as a linear regulated power supply does, and that is supply a very stable voltage over time. So that's a quick introduction. If you look on the screen, we're going to use an 80 watt switching mode DC bench power supply from Extech, and this is the spec sheet for it. All power supplies have different features, so when I show you the operation, you might not catch all the different functions that are available in all power supplies, but basically with a bench power supply, you want to plug it in, you want to have an adjustment for the voltage, sometimes you're going to have an adjustment for the current, you might limit the voltage and limit the current. Those options may or may not be there, and we're going to show you the options as they appear on this model of the power supply. This is the manual for this power supply, And if you take a look, we'll look at the actual power supply here coming up very shortly, but there's a display for voltage, there's a display for current, there's a number of indicators over here that indicate constant voltage, constant current, and an alarm mode. These power supplies can be hooked together to give more current. We're not going to cover that part, but that's what the slave light is about. The buttons that we're going to fool with mostly are here. We can turn the voltage output on or off. That's a really nice feature. We'll talk about that coming up. And this power supply, a little different than other ones. You choose between 3 different ranges. There's a 0 to 16 volts at 5 amps, a 0 to 27 volts at 3 amps, and a 0 to 36 volts at 2.2 amps. So you have to select those ranges, and then you can adjust the voltage with this potentiometer or device here, and you can adjust the current is here. These buttons down here, when we get into the operation, we'll show you what they do, review and upper voltage limit buttons. They're some neat features. Here's a little internal pot that you adjust with a screwdriver, and then here's the banana jacks for the output and the power on and off. There are a couple other sometimes useful features on the back. One is sensing, and I'm not going to cover that here, but we will in a future power supply video. So this is what we're dealing with. Let's switch over to the actual device and take a look at that, and let's fool with the operation a little bit. The first off, this output on and off is a really nice feature because power supplies have a tendency, when you turn them on with the power and they go to 5 volts, they might have a surge, and that surge might not be good for what you have it connected to. So what you do is this comes on with this off. When you turn the power on, the voltage connected to the load through these jacks here is not even there, so there is no surge in power. And then when you have your everything connected and do it, if you hit this button, you'll see this light comes on and our output voltage is there. Now I have an alarm condition right away, probably didn't want to do that. I'm going to switch to a lower voltage, and we're going to show you what that alarm is for a little bit later. So I put my voltage output on, and I have 8.68 volts, and when I go to my load over, that means that coming out of these wires is 8.68 volts. I can adjust that voltage, and this is what they call constant voltage mode. So what I'm doing is adjusting the voltage that I want to apply to my circuit with this device, and we can see the constant voltage light lit up here. But when I adjust this voltage, that is adjusting, if I put a meter right on here, it's adjusting the voltage that's across here. And this is a DC voltage, so it has a plus and a minus, or a plus and a ground, and typically computer people use red and black for that. So that shows you how to adjust the voltage. Now you'll notice that when I turn the output off, I don't see anything up on the screen, and that doesn't give me a chance to adjust the voltage before I actually hook it to the circuit. And you have to press and hold this review button in, and when you do that, you can make an adjustment to your voltage without a load connected up. And that's a really great feature, because if you turn these voltage levels with your device connected, if I had TTL ICs connected and I turned it over 5.25, I'd run the risk of messing them up. This also, when you hold this review button, and you have to hold it in, you also can adjust the current limitations. So that just means that if I did something like short the power supply out, this would only pull 1.4 whatever, I had 1.4 amps of current, and then it would go into the alarm condition and it would turn the output off. It's meant to save your equipment because things burn up and give the magic smoke or whatever you want to call it when it gets too much current. So if you limit that, your power supply might be able to save what's happening. All you from having to buy new equipment, I guess, is really there. So the review button allows you to adjust and do that. This under voltage limit or upper voltage limit, you can see when I press this button, it lights this up, and it's set for 24.8 volts. And that feature, let me turn it off again and go back to normal mode, and I'm going to switch to the 27 volt range by hitting here. And what's going to happen here is I'm going to turn my output on. I don't have it hooked to anything, so I don't have to worry. But if I have my upper voltage limit set to a certain thing, I can keep on going, turning up and turning up and turning up until I hit that upper voltage limit. And as soon as I hit that, this power supply is going to go into alarm mode and turn the output off. Let me move my hand to this side so you can see the lights go. I don't know if I can do all of them, but the alarm light will come on right when we get to 24 volts, and the output will go off. And that's why you set the upper voltage limit. If I don't want to adjust a voltage over a certain point accidentally while I have it hooked up. And there you can see the alarm go on, the voltage goes off, and this is an indication of the voltage that's on these leads at this point and hooked to your circuit. So pretty cool stuff. I'm going to put this down to the lower thing and turn this back on again. So it's there. So you do set the upper voltage limit when you have this on by turning a screwdriver in here. It's a very small pot, so you want to be careful with it, and that's how you would adjust that. Okay, turn that back off because we can't have that operating. And I think for the most part, that shows you exactly what's happening with your circuit. Now these leads are banana jacks. That's pretty standard. Let me try and move my camera around here very quickly and show you a sample of how our circuit might hook up. You can see the banana leads are coming to this board, and I'm hooking them to a breadboard. So depending on what you want to hook your power supply to, you might have to have different kind of leads, but they always have to end in they always have to be terminated with banana jacks on the power supply side. And also too, you can see my meter here, not very exciting, but you can see my meter's hooked up to the circuit and measuring that voltage. And if I turn that on my power supply, you can see that turning to which meter, the power supply or the meter, which is measuring the right voltage. Most technicians trust their meter a little bit more, but that's not always the case. You would have to get it calibrated against the standard so you knew which one was giving you the exact voltage value. But we have a tendency to trust our meter because we use it more often than we do the display on the thing. So there is a constant current mode, and we'll cover that in the future. But for the most part, we're done now. If you want to learn more about power supplies, it's a topic a little bit more involved, but also something that you're fixing the most. Wikipedia gives you a good introduction. Also to another link here to All About Circuits talks about the different kind of power supplies. So hopefully that'll be helpful.